You ever wonder how an app like Netflix can stream video to millions of people all at once while also, recommending what you should watch next? Well, the magic is all in its architecture. So today, we're going to trace the evolution of how modern software gets built, from these giant monolithic blocks to the tiny, super agile services that pretty much run our entire digital world.
We're going to kick things off with a simple but really powerful dream. This idea of stopping, once and for all, rebuilding software from scratch every single time. Then we'll see how the early web's just explosive growth created this crisis that demanded a totally new approach. From there, we'll follow the path from the first kind of complex solutions to simpler, more elegant designs, all the way up to the microservice architecture that powers today's biggest apps.
Okay, so this whole thing, it all kicks off with one simple but incredibly powerful idea. Instead of carving a new statue from a big block of marble every time you need something, what if you could just build with Lego bricks that can be snapped together in endless combinations?
And that was the core problem, right? As applications got bigger and more complicated, they became like this giant tangled ball of yarn. You pull on one thread to fix a bug, and you might just unravel the whole thing. This monolithic approach was slow, it was risky, and it just killed innovation. It was obvious something had to change.
So the solution was to think of an application less like one single genius trying to do everything and more like a team of specialists. Instead of having one massive code base, the idea was to build a collection of smaller, independent services that could talk to each other and work together. And this new philosophy got a name: Service-Oriented Architecture, or, SOA for short.
The core idea of SOA is actually really simple. A service is basically a self-contained tool that does one job and does it well. Need to process a payment? You call the payment service. Need to check inventory? You call the inventory service. Instead of building those functions from scratch inside your app, you just compose these pre-built services together.
But to really get why this new architecture was so critical, we need to rewind a bit, back to the early days of the web, because the web's own success was creating a massive problem that the old way of building things just couldn't handle it.
Yeah, in the very beginning, the web was basically just a library of linked documents. But as it just exploded in popularity, that simple model started to break. Users wanted more than just static pages. They wanted interactive, personalized experiences, and the technology at the time was really buckling under the pressure.
The real game changer was the shift from static pages, which are just simple files sitting on a server, to dynamic pages that are generated on the fly. This meant websites were no longer just documents, they were becoming complex applications. And these new applications needed a real architecture to manage all their moving parts.
So with all these new dynamic applications, a new problem popped up. How do all these different pieces talk to each other in a reliable way? Well, the answer was to create a formal standard, and that led to the very first generation of what we call web services.
Okay, so this first crack at it was, well, it was very thorough. You could say it was built for big companies. It created a really robust but also pretty complex set of rules and technologies. And the language they all spoke was XML, which is a super structured way to package up and send data.
This first system was incredibly buttoned up. Seriously, think of it like a really formal postal service. SOAP was like the standardized envelope and the official postage for sending your messages. WSDL was the instruction manual that came with it, telling you exactly how to address that envelope. And UDDI, that was like the public phone book, where you could look up the address for any service you needed to find.
And all of this was guided by some really powerful principles. The goal was to create a true Lego brick system, where all of the services were modular and independent. And this idea of being platform independent? Oh man, that was a total game changer. It meant a team writing code in Java could seamlessly use a service built by a completely different team using a different language, and nobody had to rewrite a single line of code.
But here's the thing. For a lot of web developers, this formal enterprise-grade system felt way too heavy. It was like using a sledgehammer to crack a nut. And all that frustration with the complexity is what paved the way for a much simpler, more lightweight approach.
And that new idea was called REST. Now, the key insight here is that REST isn't some new technology. It's an architectural style. Instead of inventing a bunch of new rules, REST just uses the fundamental technology that's already built right into the web, the HTTP protocol that your browser is literally using to watch this right now.
And this was the big shift. Instead of creating a whole new messaging system with SOAP, REST basically said, hey, let's just use the web's native language. Let's use standard HTTP methods like GET, POST, and PUT directly, and instead of that heavy XML, we can use much more lightweight formats like JSON. It was just simpler.
Now, this style follows a few simple rules, but the big one, the really important one, is statelessness. This means the server totally forgets about you the moment it answers your request. So why is this so powerful? Well, because any server can handle your next request, you don't have to go back to the same one. This makes it incredibly easy to add more servers to handle massive amounts of traffic, which makes the whole system both scalable and really reliable.
Another huge idea is the uniform interface. In the world of REST, everything is a resource with a simple human-readable address. You don't need all these complex commands. If you want the courses for student number 3, you just ask for the students/3/courses resource. It's predictable, it's simple, it's elegant.
Okay, so how does all of this tie into the apps you're using right now? Well, the principles of service orientation and the simplicity of REST really set the stage for the next major evolution in architecture: microservices.
You can think of microservices as taking that original SOA idea and pushing it to its absolute logical extreme. So, instead of having just a few large services, a microservice architecture breaks an application down into dozens or even hundreds of tiny, hyper-focused services. Each one does one single thing and does it really, really well.
And the advantages here are enormous. Teams can work independently on their own little piece, updating the shopping cart without any risk of breaking the user profile service. If a new movie becomes a hit and the recommendations engine gets overloaded, you just scale up that one service to meet the demand. This leads to apps that are more reliable, easier to update, and can evolve way, way faster.
But of course, there's no such thing as a free lunch, right? When you break an application into hundreds of tiny little pieces, you've basically just traded one big problem for hundreds of small ones. How do you coordinate them all? How do you test them? Managing this complex web of services introduces a whole new level of difficulty.
All right, so let's just zoom out for a second and look at the entire journey we've just covered, from one single block of code to this swarm of services.
We've moved from that single block of marble, the monolith, to a collection of powerful, reusable services with SOA. Then we figured out a simpler way for them to talk using REST. And finally, we've refined those services into this swarm of highly specialized, interchangeable Lego bricks with microservices.
And this brings us to the great paradox of modern software. We started this whole journey by breaking up monoliths into services to reduce complexity. But now we have a new kind of complexity that's born from managing hundreds, maybe even thousands of tiny pieces. The next great challenge isn't about making the pieces even smaller, it's about how to intelligently conduct this vast orchestra of services. And that, right there, is the question that's driving the entire future of software.